In the first exercise, you're going to use some facts that you're going to learn about the normal distribution to answer some probability questions. So let's suppose we've got a random variable x which is normally distributed with mean mu and variance sigma squared. Remember that sigma squared, this parameter here, is the variance. And if we were to square root the variance to just get sigma, then that would be what we call the standard deviation. And the first thing that's useful to know is that total area underneath this curve is 1. And that's because we know all probabilities add up to 1. So if you were to integrate underneath this curve from minus infinity to infinity, you'd get 1 as your total area. Next, let's look at how the probability is distributed amongst this curve. So remember, we're looking at x with this normal distribution. So let's look at what's the probability of x being within one standard deviation of the mean. So that within one standard deviation of the mean, what I mean by that is x, what's the probability of x being greater than mu minus sigma, but less than mu plus sigma. Okay, now it turns out that that probability there is always constant, no matter what mu and sigma are, and that probability is 68%. So if we were to work out this area within one standard deviation of the mean, we would get 68%. And we could write that as a probability statement like this. So it says the probability of x being greater than this value but less than this value is 68%. Well, we could move a little bit further away from the mean, and let's look at what's the probability of x being within 2 standard deviations of the mean. So if I draw in mu minus 2 sigma, we need to be greater than that, but less than 2 mu plus 2 sigma. And again, it turns out this is a constant probability. The probability of being in this region is 95% approximately. And again, I could write that as a probability statement like that. And again, we could move further away from the mean, and let's look at 3 standard deviations. So what's the probability of x being within 3 standard deviations of the mean? So that's equivalent to saying it's greater than mu plus 3 sigma, but less than mu plus 3 sigma. And that probability there, underneath the curve between those values, is 99.7%. So that means there's a 99.7% chance that x is within 3 standard deviations of the mean, either above the mean by 3 standard deviations or below the mean by 3 standard deviations. Let's use these facts to try and answer example 1 then. So we've got the diameters of a rivet produced by the machine X is modelled by this distribution. Now x is a random variable because obviously the machine doesn't do it exactly the same each time. It's random what the actual diameter of the rivet is going to be. So we've got this normal distribution, and we know that the mean is 8. So that means that on average the rivet diameter is going to be 8. And this number here, 0.2 squared, is our variance, which we've been calling sigma squared, which is 0.2 squared. Well, we could also write down what the standard deviation is. So the standard deviation is the square root of this number here, the square root of the variance, which is 0.2. And you'll notice that they've written this as the standard deviation squared, and that's quite common when you write the normal distribution, just because it makes it clear what the standard deviation is. So let's try and answer 1 then. The first thing that would be a good thing to do is actually draw a sketch of this normal distribution. So we know that the normal distribution is going to be centered around 8 because that's the mean. And we know that it's going to be symmetrical on both sides of 8. Now we want the probability of x being greater than 8. So greater than 8 is x being to the right here. So we want, what's the area underneath this curve to the right of 8? Well, we know that the total probability underneath the curve, the total area underneath the curve is 1. And we know that 8 is in the middle of the curve, so that we know that the probability of x being greater than 8, because it's symmetrical, is 0.5. Again, we could draw our curve for part B, and this time we want x being greater than 7.8, so let's label that on, but less than 8.2. So we want to work out what's this area between 7.8 and 8.2. What's that probability? Well, I've noticed that this is the same as saying what's the probability that x is within one standard deviation, the mean. Because here we've got mu minus sigma, and here we've got mu plus sigma. So using these facts that we've learnt, we know that the probability of x being within one standard deviation of the mean is 0.68. So I could just write that down. Now in this exercise you're not meant to use your calculator, but I think you might as well check your answers with your calculator. So our calculator can actually work out these areas for us. So if you go to your calculator, if you go on menu and then stat and then distribution, and then we want norm for normal distribution. Now we want CD, NCD, which stands for cumulative, because we want between two values. So we're going to put our lower as 7.8, because we want x to be greater than 7.8, but we want the probability of x being less than 8.2, so we're going to put 8.2 as our upper. And this what this is going to do is it's going to work out the area underneath the normal curve between those two values. Sigma, what your calculator wants is it wants the standard deviation. So the standard deviation is 0.2. And the mean is 8. And it's really important that you always put in the standard deviation, which is why at the start of a question I always write down what is the standard deviation sigma, because it's really common to see people accidentally putting in 0.2 squared into their calculators. And if you work that out, we get 0.68 as the probability, which is what we had here.